is an integration question. This looks really, really scary, like as if there's no way we're ever going to be able to integrate that. But we can. There's a couple of addition formulae that are going to be really useful for this question. And it's the two double angle formulae. So I'll start off by writing those down. Cos 2x can be written as cos squared x take sine squared x. It can also be written as 2 cos squared x take 1, and it can also be written as 1 minus 2 sine squared x. Just by swapping this cos squared x for 1 minus sine squared x, or this sine squared x for 1 minus cos 2x, we can get these two expressions here. And if you notice now, this 1 minus 2 sine squared x is what we've got on the top, so this can be written as cos 2x. The double angle formula for sine 2x, there's only one of them, is 2 sine x cos x. And that's what we've got here, this little section here. So this part here, we can, or the denominator, the whole denominator, we can change to 1 plus sine 2x. And that's exactly what I'm going to do. So if I box this off like that, we can now go over and say, well, the integral of 1 minus 2 sine squared x over 1 plus 2 sine x cos x dx can be written as, so we've said the top is just cos 2x and the bottom is 1 plus sine 2x. But now we've got to integrate this instead, which also looks like quite horrendous. But there's another rule, and the other rule that we can use is if we can differentiate the bottom and we get the top, then we are able to integrate the whole function, because that will give you the natural log of the denominator. And if we did differentiate the bottom, we would get 0 plus 2 cos 2x, which we've nearly got on the top. If we had a 2 on the top here, we'd be sorted. We'd be able to just differentiate the bottom and we would get exactly the top. Obviously we don't have that 2 there. I've put a 2 there because I want it there. So in order to kind of cancel that 2 out, I'm also going to need a half. Those two red constants are now equivalent to 1. So I've made the question look the way it needs to in order for me to differentiate the bottom and get the top. So now I can say that the differential of this whole thing will be this half constant at the side times the natural log of the denominator, 1 plus sine 2x. Now we can put our limits in. The limits are pi over 4 and 0. If we put pi over 4 in, we're going to have a half ln of 1 plus sine of pi over 2. Sine of pi over 2 is 1 minus a half ln of 1 plus sine of 0, which is 0. So we've got half ln 2 minus ln of 1 is 0, so minus 0, which is just half ln 2, which is what we had.